Lesson 2.2 is simplifying radicals with x. So now having variables underneath the radical. Okay, so if I had the square root of 7, I cannot do anything with that. 7's a prime number, so there's going to be no factors that go in it. Remember my perfect square numbers that we wrote down? Nothing from this list will work. So I already know I'm going to have a square root of 7 kind of in my leftover pile. So I'm still going to split this into two radicals. Square root of 7's here, no number here. Now this x to the 12th, I want to think about if you had the square root of, let's say, 10 squared. What does 10 squared equal? 100. What's the square root of 100? 10. So see how this really got you back to 10? What that tells me is that a square root symbol and a squared cancel each other out and you're left with this. So what if I had a square root of x squared? Well, this and this would cancel, leaving me with just x. So then what happens is every even number, so since this index is 2, we need this power to divide by the index. Since 12 does divide by 2, I'm going to put them all here. So all you're doing is 12 divided by 2, which is 6. You're saying how many pairs are inside of this? 6 times the square root of 7. It'll get easier once you see the pattern more. Okay, number 2, we've got x to the 5th times a square root of x to the 11th. So this is what we're trying to simplify. Remember our index here is 2, so I need this to be a multiple of 2. Can't go bigger, can't add to your x's, but let's go down to x to the 10th. So I'd have square root of x to the 10th times, how many more would be x to the 11th? Times another x. So that's 10 plus 1 is 11. So then what we have is our x to the 5th. 10 divided by 2 would be x to the 5th. And then times this leftover square root of x. Simplify this. Remember, when we're multiplying exponents, we add the power, so it'd be x to the 10th square root of x. So again, you're just trying to make this be a multiple of 2. So you break it into whatever's the lowest multiple of 2 or next lowest multiple of 2, and then you have your leftovers. Let's try it again. Number 3, we've got 6x squared times the square root of 4x to the 5th y to the 5th. Okay, so I'm going to break this into something that is perfect square, something that is not. 4 will be a perfect square. X to the 5th is not because it's odd, but I could bring it down to x to the 4th. That would mean I need one more x to make x to the 5th. Same thing with the y's. Y to the 4th and another y. So I should be able to square root this whole radical. Square root of 4 is 2. 4 divided by 2 is squared. 4 divided by 2 is y squared. Leftover square root of x, y. 6 times 2 is 12. X to the 2 plus 2 is 4. Y squared, square root of x, y. So your answers get pretty crazy looking, but that's what it is. All right, one more. 2x squared, y squared times square root of 75 x cubed, y cubed. All right, we're breaking this up. Perfect stuff, non-perfect stuff. 75 is not a perfect square, but think of quarters, 3/4. So the perfect square number that goes into 75 would be 25. So that goes here. 25 times 3 makes 75. X cubed needs to go down to x squared and then a leftover x. Same thing with the y. I should be able to square root all of this. Square root of 25 is 5. 2 divided by 2 would be an x and a y. This is left over. Times your 2x squared, y squared. 2 times 5 is 10. X squared times another x would be x cubed. Y squared times y is y cubed. Square root of 3x, y. Okay, so anytime you're square rooting, you need your variables to be multiples of 2. If it's not, bring it down to the next closest multiple of 2 and then have your leftovers in the other pile that stay under the radical.